What's the formula for a period? Now, I didn't tell you this was degrees or radians, so you have a choice. So if I don't do that in the exam, you can write either. By the way, if I stipulated that it was degrees, then you really must do the answer in degrees. So what's our period? Let's go degrees, yeah. Period of a sine curve.
A normal sine curve?
Yeah, of any sine curve.
360.
Of any sine curve? That's of a specific sine curve. So the one you just told me is this one. Or this one. Or that one. You've told me about that sine curve. So how do I make it any sine curve? Now what I'm going to write here? I'm going to write that as an NX and talk about that in a weird way. So now it's any sine curve. Some people, by the way, will write it as A sine Bx plus C plus D. And then really any sine curve. So they're the only things you can change on a sine curve is those four things there. But the funny part is we'll call it B there, but up here we'll call it M. Do you remember the formula?
It's
360 over N. That's 360 on 2, so its period's 180 degrees. Yeah? Mac, amplitude.
10.
Yep. I have to think about that one. So that threw you off for a second, that bit there. So I want to nag about a little bit and go 360. I think I nagged enough. You'll be right with that. So it's 10, amplitude's 10, so there's your amplitude. So is that, Mac, is that actually the period? That number there, is that, what's that got to do with the period?
That's what you divided by.
Go. So we've got period, we've got amplitude, coordinate of A max. Not easy to tell. You're actually better to graph it first. So in order, I would probably go to the graph next. Let's have a look. What do we got? Have I left myself enough room? So Mac,
Yeah.
out of those numbers that are there, which number is probably the most important? The 10, the 2 or the 5 when I go to draw a graph?
To start with, probably 5.
Yeah. Come up here to 5. The sine curve normally starts at 0, 0, but this one it won't start at 0, 0, it'll start at the 5. A lot of people would put a dotted line, it's not an asymptote. That's going to go up to 10 and down to 10. Cam, is this going to go up from there or down from there? Up. Now before I go up, well, I could do this first. I could just go up, come back down, but then you've got to go, wait a minute, how far up do I go? Is that incorrect? Josh, is that incorrect if I started drawing that there and that was a 10 and that was a 5? If that's 5, I've only gone up, looks like I've only gone up how much? 5, which that says, Josh, I have to go up by. So I really need to extend this and make a little bit of room here. And go, get rid of that. Be realistic, I've got to go up here to 15 and I've got to go down here to -5. So there's your amplitude, up 10 or down 10. So we're going to go up 10, down 10, down 10, up 10. I tried to make it reasonable. That's pretty accurate. You get away with that without any problems at all. But we also know that, if I went down from there, that is the length of the cycle. And the length of the cycle is the period. So this sine graph takes 180 degrees to repeat itself. So if I started there, by the time I get back to there, that's the period, which is the length of the cycle to repeat itself. So that's 180 degrees. Josh, at that point, do I need to draw any more? Do I need to draw more of this? It didn't stipulate to go further. It didn't stipulate you can't go further. So if I had written up here that this one was for naught less than or equal to x less than or equal to 180 degrees, yeah, I'd have to stop there, but it didn't stipulate that. So personally, Josh, I'd put a little arrow going on that way, and I'd probably put a little arrow going back that way and make it a bit more fuzzy. So what's that one there? There's your max. Ben? Ben? How do I get the coordinates to that point?
Y will equal 15, but X.
Yeah, you've got 15 x's.
Hold up. 45.
See,
Yeah, 45.
that's 90. A halfway would be. This where you get dotted lines all over the place, doesn't matter. It's not really. So 45 degrees and 19, there's the coordinates of your max. Coordinates of the min. Yes, Mac.
So can you just write it as a degrees, or do you have to?
Yes, you can just write as degrees.
Yeah. Okay.
Yeah. So this one here will be. So my brain thinks in terms of half the 180, half the 90. We're looking at lots of 45. So I go add 45, and I'm at 135 degrees. So Ben, how far down to go?
-5.
Too easy. And if you wrote that was a max and that was a min, you've got 4 marks as long as you rubbed off the amplitude. 10. Okay? Can I go through this really quick? I'm going to leave myself a fair bit of room, so I've got a 20, and I'm going to start at 30. So I could go up to here and say that's a 30, because of that's 30. Not an asymptote, remember? My brain then goes period, 360 on what? 360 on the 5, so that 5 is there. 5 into 360. 5 into 36. 5, 7, 35. 1 left over. 5 into 10 goes 2. So at that point, I'm not going to write 32 on it. I would rather do the graph and then add the 72 on afterwards. So where's it going to start at? Does a cost graph start up or start down or start in the middle? This one will start up 20, so it's like, this is like up 20. We go, if that's 30, make it realistic, it's 50. Starts up there, comes down, goes down to 10. So up 20, down 20 from 30. Dash. Up 20, down 20 from 30. You see it in your head before? So I'm going to go down to there, go up to there, up to there. And probably at that point in time, I'd just then go, that's 72. And I go, I want halfway, that's 36. And I want halfway again, and that is 18. And I just go 18 and 18 and 18, that one there would be 18 and 36. 54. Yeah. 54 degrees. Questions done. What you have to write in is a maximum in, by the way, it didn't stipulate, so I'd probably go an arrow that way and arrow that way. Would it matter which max you wrote? No. 72. So Mac, you're right, the degrees, it looks funny writing it in degrees, doesn't it?
Yeah.
It's like almost like it feels wrong. That one would be 36 degrees and 10. And we're done. I didn't say amplitude. Amplitude's just a 20.